Alright, welcome everybody. Let's do this AP Calc lesson number 38. So here we're going to be going through related rates problem, but with a slight little twist. Let's try and look at the first question here. It says the area of a square is decreasing at a rate of 56 square inches per second. At the time when the side length of the square is 3 inches, what is the rate of change of the perimeter of the square? Round your answer to 3 decimal places if necessary. So what I'd like you to do is first try and do the essentials, right? What's given, what do you know, and what are you trying to find? So here, let's say you pause the video. Let's look at the first sentence. It says the area of a square is decreasing at a rate of 56 inches per second. So how can you translate this sentence into some sort of mathematical equation? This is dA dt is increasing, so it's positive, so it's 56 inches inches squared per second. Okay, so that's the first part. Then it states at the time when the side length is of the square is 3 inches. So here, how can we translate this sentence here? We're just gonna say that S is equal to 3 inches. What is the rate of change of the perimeter? So how do we translate this part here? What is the rate of change of the perimeter? That's what the question is asking us to find. It's asking what is the capital P dt. Okay, and this represents the perimeter. So what's actually happening in the problem? It's saying you have some square, right? And you know that the square, the area is increasing in your square. So notice that the area is what we're talking about on the inside over here. Notice that the area keeps increasing. Okay, so now what is the question asking? It's saying, how does the perimeter change? So what are some things that we know? How do you find the area of a square? So if I have any square just like this, you know the side length is S. How do you find the area? It's just S squared. Okay? How do you find the perimeter of a square? You just add up all the sides. So it's S plus S plus S plus S. It's 4 S's. So that's it. It's 4 times S. Okay? Now, what is the question asking? It's asking us what is dP dt. Now, how can we find out what dP dt is? How will that help us out? Like, what would you do to find dP dt? What do you think the first move would be? Let's see. Your first move, let's take P is equal to 4S. And now here, we know that we want to take the derivative on both sides. So here, let's take, let me get my pen, and let's zoom in a little bit. We want to take, my bad. You want to take d dt on both sides. d dt. So now what would this equal over here? The capital P dt is equal to, well, what's the derivative of 4s? It should just be 4 ds dt. Okay? Now, we have a little bit of a problem here, because once we get to this point, you want to find what dp dt is. But what are we missing? We're missing ds dt. We don't know at what rate the side of the square is increasing per second. So let's see. How do you think we could actually find that? Let's use the information we have. Notice you also have this. You have a is equal to s squared. And what other piece of information you have, you know what dA dt is. So let's play around with this. What happens if we take d dt on both sides? Okay. Now this becomes dA capital dt is equal to, well, what's the derivative here? It's 2s ds dt. So notice we have dA dt is equal to 2 s ds dt. How would you continue? Because you want this, but notice to get this dp dt, we need to find this. Do you have enough information to actually get ds dt by itself? Yes, you do. Okay, notice that what is dA dt? dA dt is this 56. So notice that this 56 is equal to 2 times, do we have s? Yes, we do. What is the value of s? S is 3. So it's 2 times 3 ds dt. Now notice we're going to get ds dt by itself because here 56 is equal to 6 times ds dt. So then how do you get ds dt by itself? We divide both sides by 6. And now you have ds dt is equal to 56 over 6. What is this, like 9 point something? 56 divided by 6. It's 9.333 bar. Right? Cool. So you know that ds dt is 9.33 bar. Now we could take this ds dt and then plug it in over here. So now we have d capital P dt is equal to 4 times this 9.33 bar. And then this should be, what will it be? What is 4 times 4? 37.3333. So dp dt is equal to 37.333 bar. And that's it. We found dp dt. Now what I'd like you to do is take a second and ask yourself, what does the solution mean in context of the problem? What does this dp dt represent with the visualization of the square? Okay, try and answer that by yourself. But here, if you want to see how it's done, d capital P dt represents the perimeter of the square is increasing by 37.333 bar inches per second. Sorry, inches per second. Every second, when this rectangle's area keeps getting bigger, the perimeter on the outside is getting larger as well. And that's the idea of this question. Okie dokie. Okie dokie. Let's look at the next one. Here, what shape are we going to have? We're going to have a circle. So let's take a look at this one. Here, the area of a circle is increasing at a rate of 41 square feet per minute. At the time when the area of the circle is 16 pi, what is the rate of change of the circumference of the circle? And I'll explain what this means, circumference, just in case if you forgot. What I'd like you to do is try and go through the question and what do you know? What do you want to find out? Here, let's look at the first sentence. It's saying the area of a circle is increasing by 41 square feet per minute. So how can you translate the first sentence? You could say d capital A dt is 41 square feet. So feet squared per minute. Okay, that's how you would translate the first sentence. The second sentence says at the time when the area of the circle is 16 pi. So here, when you know that A is equal to 16 pi, what is the rate of change of the circumference? So now here, how would you translate this sentence over here? What is the rate of change of the circumference? I'm sorry, the rate of change of the circumference of the circle. You want to find d capital C dt. Okay, so let's first visually understand what's going on. You have a circle. Okay, now when we talk about the area of the circle, this is the area of the circle in the blue. So the area is here, the blue. It's how much is on the inside. When we talk about the circumference, it's the idea of the perimeter. When we talked about the perimeter of the square, we talked about the distance around it. So here, what is the circumference of the circle? It's the distance of around the circle like this. That is the circumference, okay? Now here, it's saying that the area is increasing. So you have a circle like this, then like this, and here, the area and the circumference keeps increasing. So do we know the given formulas to find area and to find circumference? How do you find the area of a circle? This you have to know cold, right? This is, pause the video and think about it, pi r squared. Now, the circumference of a circle we haven't really talked about, but it is from geometry. It's 2 pi d. Okay? 2 pi d. Now, what do we want to do? We want to find, and what else do you know? That if you have a circle, and this is the radius r, what is the diameter with respect to r? The diameter is always 2 times the radius. That's also true. So you know d is equal to 2r. So these are some given formulas that should be solid. Now here, what do we want to find? We want to find dc dt. So what would you do first? Which one of these would you take? Right? Let's take c equals 2 pi d. Right? So 2 pi d. Now what are we going to do? Let's take d dt on both sides. Okay? Now notice you have d capital C dt is equal to, now how do you take the derivative of 2 pi d? What I want you to do is pause the video and try and do this by yourself. What is the capital of 2 pi d? I'm sorry, the derivative of 2 pi d. Here, notice 2 pi is a constant. So notice that you're just taking 2 pi out and you're taking the derivative of d with respect to time. So all it becomes is dc dt is just equal to 2 pi, oh boy, dt. Oh boy, that was a little tricky because this letter d represents diameter. So now we have a dt. Oh boy, that's a little confusing. Okay, now notice we want to find this dc dt. But we have a problem that we don't know what dt is. So what do we want to find, or how can we use the information we have? Let's take a look at the info we have. We have this dA dt, right? And we know A is this. Oh, you know that A is this. Okay, so that makes sense. So let's see if we take the derivative. If A is equal to pi r squared, what is the derivative of this pi r squared with respect to time? So let's take d dt on both sides here. D dt. Now you know that d dt is dA dt is equal to, what's the derivative of pi r squared? It's 2 pi r dr dt. Okay? Now, let's take a look. How does this help us? How does this help us? Because here we have dA dt is equal to 2 pi r dr dt. Now here, do we know dA dt? We do know dA dt. dA dt is 41 is equal to 2 pi. Now, do we know the radius? We need to find the radius. How can you find the radius? Oh boy. Now let's take a look here. To find, what does the radius equal? Well, do you know the area? Notice that the area is equal to 16 pi. So if you know that the area is 16 pi, we could plug this area into here to find the value of r. So now here, this becomes what? This becomes 16 pi is equal to pi r squared. So now if we divide both sides by pi, then 16 is equal to r squared, r is equal to 4. Awesome. So you know r is equal to 4. So this is times 4. But now we need a dr dt. How do we do this? I'm a little stuck right now. I haven't done this. I thought I could just do it on the fly. But I need to pause the video and think about this. How do you do this problem? What is dr dt? I'm guessing you know that d, instead of, okay, I see. So notice that, so you have the circumference, right? It's 2 pi d. But you know d is equal to 2r. So what you could really say is that c, you just substitute this d equals 2r in here, so then c is equal to 2 pi times 2r, so c is equal to 4 pi r. Now, why did we want to do that? Because here, if you have 4 pi r, this, instead of doing 2 pi d, let's do 4 pi r. And if you take the derivative of 4 pi r, then the derivative of 4 pi r is 4 pi dr dt. Now, we want to find dr dt, but that's okay because over here we have dr dt by as the only variable. So now this becomes what? Oh man, this was a lot tougher than I thought. But 41 is equal to 8 pi dr dt. Now here, let's get dr dt by itself. So 41 divided by 8 pi, because you're going to divide both sides by 8 pi. So this is dr dt. So now what is 41 divided by 8 pi? Oh boy. Calculus. 41 divided by 8 pi is 16. So you know that dr dt, I bet you some of you are like, Mister, you are beastin'. 16.1006. Let me just write this over here. Dr dt is equal to 16.10066235. Great. So now that you know that dr dt is this, we could plug in this dr dt over here to get dc dt, which is what we're trying to find. So now you just do 4 pi times this number here. So we could just go to the calculator, times it by a 4 pi, and now we get that dc dt is equal to 202.327 because you're going to round it, right, to 3 decimal places. So you know that the circumference is increasing by 202.327 inches per, I'm sorry, not inches, it'll be feet per second. Whew. All right, dc dt. All right, now, for what did I want to actually do, notice that in this we had one problem with a square, one problem with a circle. What's the next problem? A cube. And what's the final problem? It's a sphere. And notice we're going to talk about surface area. I think for your mental sanity, let's just stop for today. And what I want you to do is, for Delta Math will either give you a square, a circle, a cube, or a sphere. What I want you to do is try and do at least 3 problems with either a square or a circle. Okay, the circle might be a little bit tougher. But go to the Delta Math. If you get like a cube or a sphere, skip it. Just, we'll do that one tomorrow. But try and get 3 questions right with a square and a circle. All right? I will see you tomorrow, and we will discuss everything about this. Enjoy.